Phil, back for some more MCAT podcast. How are you today?
Doing great. The birds are singing. Summer is here. It is hot.
Summer's here. The heat is definitely... I was hoping with so many fewer cars on the road because of COVID and the stay-at-home orders that we'd have a little bit cooler winter, or cooler summer. But I guess it doesn't happen that quickly.
Right.
See.
Yeah. I wish. It's definitely been a scorcher.
Yes. So we are continuing our breakdown of Blueprint MCAT, formerly Next Step Test Prep, Blueprint MCAT Full Length 1, which everyone can get free access to from blueprintprep.com, which is awesome. We are on to question 27 here in the first section, the Chem Phys section, and we are into our second set, I think, of discretes for this section.
Yep, second set. We're passing on. We're past the halfway point now of the Chem Phys section. It's all downhill from here, right?
It's all downhill. Coming around the home stretch. All right.
Actually, we have. If this was test day, we'd still have 5-6 hours still to go through.
Yeah, well, who's counting?
Yeah.
Everyone is counting.
Right. Exactly.
All right. So let's dive into this first question here. This first discrete question. A book rests horizontally on a table. The book experiences a gravitational force of mg, mass times gravity, I'm assuming that's what that is, due to the Earth's gravity. According to Newton's third law, A, the book experiences a normal force of mg pushing up due to the table. B, the Earth experiences a gravitational force of mg from the book. C, the table exerts a gravitational force of mg on the Earth. Or D, the Earth exerts a normal force up on the table equal to mg plus the weight of the table. Oh. All right. So gravitational force, mg, is that mass times gravity? Is that what that is?
Yep.
Okay.
Exactly.
All right. So gravitational force of mg due to the Earth's gravity. So that's the book is experiencing that force. Okay. The book experiences a normal force of mg pushing up due to the table. So that would kind of make sense because I'm like, well, if mg is pushing down, then you have to have mg pushing back up so that the book doesn't go anywhere. The book's not falling through the table. All right. So just to clarify the question, it's not asking for an everything but an except answer. So this is looking for an right answer, a right answer. B, the Earth experiences a gravitational force of mg from the book. Poor Earth. Be nice, book. I guess that kind of makes sense, but I don't know. C, the table exerts a gravitational force of mg on the Earth. So you would assume that, well, if the book experiences the force onto the table, then the table must exert a force onto the Earth. But what if there was a floor between the Earth and the floor? Then we're like, oh, the table's on the floor, not on the Earth. It doesn't say if this table is outside on the grass or inside on a floor. So I don't know. This is the mind that a pre-med goes through. But what if it's grass versus concrete? Is concrete technically Earth? Oh, I don't know.
Right. What if it's a clay floor?
Yeah.
Clay tiles. Does that count as Earth, or is that?
Yes.
Right.
Is this in a high rise? Does every floor in a high rise decrease the amount of force? Yeah, this is where my mind goes, and I start freaking out, and this is why I run out of time every time I take the test. D, the Earth exerts a normal force up on the table equal to mg plus the weight of the table. So it's interesting. So D and A almost like seem like they're saying the same thing, that the book experiences this force pushing up from the table, and the Earth also exerts a force up on the table to the book. So to me, my logic wants to tell me that A and D are somehow the same. So that obviously two answers can't be the same. So neither of those must be right.
Very, very clever.
Yeah.
It's kind of like looking at the relationships of the answers to each other. I always call that MCAT judo.
Yeah.
You're using the exam against itself. Like you
Yes.
use your opponent's weight against them.
Okay. So then I'm left with the Earth experiences the gravitational force of mg from the book, which, okay, maybe. And the table exerts a gravitational force of mg onto the Earth. So here's the problem with my MCAT judo, though, is those questions both seem similar as well. Or those answers both seem similar. Yes, the book is exerting a force onto the Earth, but it's through the table. And so could you say the book is exerting the force or not? The table obviously is connected to the Earth closer than the book. So I'm going to go with C because my brain hurts at this point, and I'm just going to move on.
Yeah. So this is one of the questions that is probably one of the most missed questions on this exam.
Really?
Yeah, it is. And it's just a little discrete question. There's not a lot of crazy data interpretation or anything like that. Mm-hmm. A lot of students get into the idea of their and I noticed you were kind of doing this a little bit as well. You were kind of like going through each of the answer choices and just seeing if they made sense or didn't make sense and looking at the answer choices kind of on their own.
Yep.
It's something I was battling with a student with earlier this week. This was kind of like their big mountain to climb. Is they would go through the answer choices and they would start to kind of like work through that. So imagine you had a question like, why does Phil buy gas, right? And you could have answers like cars run on gasoline. Mm-hmm. Phil has a dog. The sky is blue, and apples are fruit. Mm-hmm. And like 3 of those are true statements, but not the right answer to that question, right? I buy gas not because apples are fruit, even though that's a true statement.
Yeah.
And so actually more than one of these answers is a true statement. But the question is very specifically asking, according to Newton's third law. Mm. And so Newton's third law is one of my favorite equations in that it's one of the equations that everyone knows.
Oh, wait. Okay, stop right there.
Okay.
Is Newton's third law the equal and opposite reaction?
That's it.
Oh, yeah. So
every action has an equal and opposite reaction.
So based on that, the answer would be then the answer is either A or D, right? Which one's exerting the force?
Yeah, I'm going to finish this idea.
Yeah.
Everyone knows this equation and this idea.
Yeah.
Nobody understands. It's like E equals MC squared. Everyone knows that equation, but very little people know that's for like calculating mass defect of like combining nucleons and like.
Of course.
Like no.
People don't know that.
Equation. Right. Yeah. Imagine that. But this reactionary force. If I were to, like, let's say I was riding around with my friend Tyler and I saw Volkswagen and I like slapped him because we play Slug Bug, and I like hit his face with my hand, his face is gonna sting, but so's my hand.
Yep.
Because as hard as my hand is hitting his face is hitting my hand, and so those are contact forces. And so an important thing with reactionary forces, which is what Newton's third law is about, is that they have to be between the same 2 objects, and it's got to be the same 2 types of forces. So if I have like charge A pulls on charge B with electrostatic attraction, then charge B pulls on charge A with electrostatic attraction.
Okay.
And so it's got to be the same type of forces, and it's got to include the same 2 objects.
Okay.
So looking at what's going on here in the question, they say the book is experiencing a gravitational force due to the Earth. So the Earth is pulling the book down, which means with gravity, which means the book must be pulling up on the Earth with gravity. And so the correct answer here is actually going to be B.
Yeah.
Now, as you mentioned, A is true, right? The table is pushing up on the book, and that's what's stopping the book from like rocketing through the table or like speeding up into the sky. Mm-hmm. And so the normal force and Earth's gravity force are equal and opposite, but they're not reactionary forces, because reactionary forces have to be including the same objects and the same types of forces. Okay. And so I think a lot of students end up just looking at this and like, yeah, A is true. And then they pick A. And like 60% of students pick A for this one because it's just a true statement and they just kind of like read through that. Yeah. But we're looking specifically for a reactionary force.
What's the difference between normal force and gravitational force?
So the normal force is how hard the table is pushing up on the book. So like imagine that I was like laying on the floor and you stood on my stomach.
Yep.
Gravity is pulling you down.
Yep.
And I am pushing you up.
Yep.
Right. And so the normal force would be me like lifting you off the ground and kind of like applying that upward force. As much as I'm lifting you up, you're smushing down on me. And that's a contact force. So I'm pressing up and you're pressing down. So I feel you squishing me and you feel me lifting you in that scenario. So those would be reactionary forces.
Okay.
Now, the Earth is pulling you down and you're also pulling the Earth up, which seems weird, but the Earth is huge. Yeah. Right? Like if I tied a rope to an aircraft carrier and I pulled on it, it's not really going to move because it's too big. And the Earth is, I guess that's actually kind of an aircraft carrier by itself. It's just the largest aircraft carrier. It's carrying all the aircraft.
Yeah.
And so that's hardly going to move as well. So just because the Earth is so massive, pulling on it a little bit is not going to make much of an effect on its movement at all.
Okay. So this is one of those like, oh, it's a tricky question, but it's not really a tricky question. It's a very specific definition question. So Newton's third law, you have to know equal opposite, but also equal opposite of the objects and of the type of force.
Right, exactly.
Okay.
So reactionary forces, if one's a gravitational force, the other one's a gravitational force. If one's electrostatic, the other one's electrostatic. If one's contact, the other one's contact.
Got it. All right. So B it is. All right. So the Earth is budging just a little bit because of that book.
Yeah, as I mentioned, that's one of the most missed questions. It's actually less than 25% of students actually get that question correct.
Wow.
Which means they should probably just randomly guess on that one, and you would get about 25%. You'd be doing better.
There we go.
So 28 is the next question, and this is a question about nitrogen. So nitrogen primarily exists in the atmosphere as a diatomic gas. Which of the following is true about this form of nitrogen? So we have the presence of a lone pair of electrons on each nitrogen atom, and the molecule allows it to act as a strong Lewis base. The triple bond of electrons create a region of high electron density that allows N2 to be very reactive as a nucleophile. Diatomic nitrogen is relatively inert and can be used as the atmosphere in laboratory conditions to prevent unwanted side reactions. And D, atmospheric nitrogen reacts spontaneously with carbon dioxide, which keeps atmospheric CO2 levels at a relatively low 0.04% on a molar basis of the atmosphere.
Yeah, based on my complete lack of knowledge of nitrogen as a diatomic gas in the atmosphere and anything about it, I would choose C and move on because C never lets me down.
Yeah,
except when it does.
You'd be right. You get this question. So this is kind of like this like sort of specific subset. You can reason through a lot of questions if there's like a passage attached. You're really good at kind of like working through and just kind of understanding the connections between things. But obviously you haven't like sat around and studied the periodic table for quite a while. And so it turns out that when we breathe in, 70% of the air that we breathe is actually nitrogen gas. Oxygen is like 20%, and that's the next highest. Then after that's like CO2, and then just everything else is the last 5%. So note that it doesn't really do anything. Most of the air we breathe is nitrogen, doesn't make any effect at all, and so diatomic nitrogen is going to be pretty inert because the nitrogens are held by a triple bond, and so B is correct, in that there's a triple bond between these two nitrogen atoms. But that makes it not reactive because it's just like really tightly held together, and those things don't want to interact with other things, which helps you eliminate B and D because it's really unreactive. And also, nitrogen is not going to be a strong base. If that was the case, then we would like breathe in nitrogen gas, and our body would become like we would get like chemical burns from the alkaline activity of the air. That
wouldn't be comfortable.
No, that would be not good.
Yeah. So really, the potential logic that could have been pulled into this is understanding that nitrogen is in the atmosphere. It's a huge part of the atmosphere. And if it was a strong base, would that make sense in the atmosphere? What would that potentially do to us, to the environment, et cetera?
Or really reactive, because then we'd have like chemical reactions and we'd have to like worry about like all sorts of damage. And so A, B, and D, we're all kind of talking about this like really highly reactive nature. And that's not going to be the case. We don't even notice nitrogen in the air.
Okay. Awesome. All right. So logic could have helped. I think I just went to an extreme of like, oh, I don't know anything about diatomic gas. I'm like, no, it's telling me just basically nitrogen is a diatomic gas in our atmosphere.
Right.
Okay.
And so that's a really common thing where on the MCAT, and this hurts a lot of students as they're prepping for the MCAT because they're used to an undergrad reading like if they're tested on something, they're expected to just know it versus the MCAT is a lot of puzzling. And so you can kind of like look at this and they kind of gave you some clues that there's a lot of nitrogen in the air. Which of these makes sense? I'm like, well, I breathe air and I'm fine. So it's probably not reactive or alkaline.
Yeah. Oh, all right. So really just calm down, read, and think. It's amazing what a deep breath can do. All right. Question 29. Which of the following is closest to the bond angle between the carbons in a molecule of acetone? A, 90 degrees, B, 109.5 degrees, C, 120 degrees, or D, 180 degrees. Oh, all right. So I would have to potentially understand what acetone looks like. And all I know is that it comes in a bottle and my wife uses it to take off nail polish sometimes.
Right, exactly.
That's the only shape that I know.
Yeah, I know the smell of it. Right?
Exactly. Yeah. So this is interesting. Why is acetone so special here, right? We're told, oh, you should know the amino acids and what those look like, and what's special about acetone here?
Yeah, so I think actually even more importantly is the kind of like breaking down the name, like ACET, like an acetyl group. So acetyl means two carbons with a carbonyl attached to it. And so that's where we have like acetic acid, which is vinegar, acetyl-CoA, which is like a big part of metabolism. As you get into the like molecular genetics, they'll talk about like acetylating a histone, which just means adding an acetyl group to it. And then acetone, obviously, as well. And so all of these have kind of like the same basis in terms of molecules. And so I think knowing like what an acetyl group looks like is kind of useful because it shows up all over the place. But I think just as important is the second half of that word, which is -one, which just means ketone. So if you have a ketone, that means you've got a double bond oxygen in the middle of a compound. And so if I've got acetone, that tells me that I'm going to have a carbon double bonded to an oxygen. Now, carbon normally has 4 bonds. And so if one of those bonds is a double bond, then it's going to have 2 other bonds. And so this acetone molecule is just going to be connected to 3 things total, the oxygen and then 2 other carbons. And so after that, you can just kind of like use geometry to figure out like, oh, it's probably going to go like 360 degrees. It's going to look like a peace sign as this kind of orients. And so it's going to be about 120 degrees between each one. So even if you're unsure of the structure of acetone, and let's say you didn't even know the acetyl group thing, you definitely want to know that own like subscript. That's not even the right word, but like the second half of the word. And so that happens big with like ketone bodies and metabolism. And so anything with like any functional groups involving carbons, oxygens, and nitrogens, you want to be really comfortable with, like carboxylic acids. If you see anything that ends in oic acid, like propanoic acid or acetic acid, you want to know those structures, just because carbon, oxygen, and nitrogen are what we build our bodies out of. And so the MCAT cares a lot more about those sorts of functional groups.
Okay. All right. So my handy dandy pixie and move on would have worked very well there as well. All right, and then last question here for this set of discretes. A circuit is constructed with a 12-volt battery and 4 identical resistors, each with a resistance of 16 ohms, hooked up in parallel. What is the total power dissipated by the circuit? A, 4 watts, B, 4 joules, C, 18 joules, or D, 36 watts? So 12-volt battery and 16 ohm resistance, 4 identical resistors hooked up in parallel. So I can picture, right, having a battery on one end and then 4 kind of things coming off of it, each with the 16 ohm resistors hooked up in parallel there. And so basically the question is what's coming out on the other end. And I used to love this sort of math. Right? I was a huge nerd way back in the day with like growing up and speaker systems in the car and trying to figure out the resistance for the speakers and the power needed to power them and all this fun stuff.
Yeah,
but
get the right fuses for the circuits and right.
Yeah, but anymore, I don't know. So obviously there's a conversion here with volts and ohms back to watts and joules. So potentially the first step would be which one of these what do you call these things? Which one of these units is correct versus not, watts or joules? So
yeah, that's definitely where I'd want to start, because with zero knowledge, zero calculations, if you know the difference between a watt and a joule, you're down to a 50-50. Worst case scenario, which is a great place to be if you just know your units. Do you have any thoughts on watts versus joules related to power?
No, nothing useful that comes to mind.
Yeah. So power is measured in watts. So that means it's got to be A or D. So power and watts is a measure of energy change over time. So if I have a 60-watt light bulb, that means it's burning 60 joules every second. So a watt is just a joule per second. So B and C are both joules. That's not power. Power is a joule per second. And so you can get LED bulbs, which are 17 watts. And so they burn about 1/4 the energy of your normal 60-watt light bulb because they burn 17 joules every second. And so just off of that, we think the answer is probably A or D.
So explain the difference real quick again. So what's joule specifically?
Yeah. So a joule is a measure of energy. Okay. So however much energy. Okay. So if a light is on, like the photons being released, there's some amount of energy there that's being put out. Especially if it's like not an LED bulb, then there's heat released as well as energy, and that's why the light bulbs get hot. But the power is a joule per second. So it's kind of like the difference between like miles and miles per hour, right? Like that's definitely a difference between those.
Okay.
And so the other half of this is the circuitry stuff. So even if we know we're looking for watts, we're down to A or D at this point, which is, awesome because I haven't done anything. I just know what a watt is. And so at this point, we got to figure out the total power. And so the power of a circuit, we have power equals IV, which is current times voltage. The way I remember that is all the powerful drugs are in the IV poles. And so just kind of relating that back to medicine, all the good stuff, right? Power's in IV. And so because P equals IV, we got to figure out what the current is, the total current of this circuit. They give us the voltage, so that makes that easier. So we just need to find the current and multiply that by the voltage. Okay. The issue is we don't have the total resistance of the circuit. If we had the total resistance, we could just use V equals IR and we'd be done. But we have 4 resistors. And so we got to figure out what the total resistance of this circuit is. Yep. And so because all of this is in parallel, your equation for resistance is 1 over the R resistance, the total resistance, is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. So the equation is going to basically break down to 1 over R resistance is equal to 1/16 plus 1/16 plus 1/16 plus 1/16, which is going to be 4/16, which simplifies to 1/4. So our actual resistance, 1 over R resistance, is equal to 1/4 or 1 over 4. So that means our resistance has to be 4. And so our total resistance for this circuit is going to be 4 ohms. And then you can use P equals IV going through this. And I feel like my math is ending up off. So we have the resistance is 4, sorry. And so we have V equals IR to find the current. And so the voltage is 12, the resistance is 4. That means the current is going to be 3 because we have 12 equals current times 4, V equals IR. And so our current is 3, and then we know our equation for power is power equals IV, so that's just going to be 3 times 12. This question takes a lot of steps to move beyond that 50-50 position. To get to that spot where you're down, I know it's a watt, it's A or D. That's a great place to be in. To go beyond that, it requires you to know several equations related to circuits, both the power, Ohm's law, which is V equals IR, and how to deal with resistors in parallel. So there's like 3 extra calculations they have to work in on top of that.
So looking at all of those steps, the big thing that stands out to me with the power equals IV, right? We have V is 12. When is that I is impedance? Is that what I is?
Current.
Current.
The amps per second. It's
okay.
the amount of charge moving through the wire.
When is that going to be less than 1 to where the power is going to be less than the 12-volt battery?
Yeah. So if I hooked up a bunch of resistors in series, then the resistance is going to keep going up in that case. If I hook them up in parallel, that allows the current to just go through one resistor and not through the rest of them. So if I were to hook up all these resistors in series, the total resistance, you would just add them up. And so that would be, 64? And so if we had these 16 resistors in series, the total resistance would be 64 ohms, which means V equals IR, our resistance would be huge and our voltage is still 12. So that means our current is going to be like point something. It's going to be like less than a fifth.
Okay.
So it's going to be 0.1 something.
So is that a potential shortcut to go, oh, these are in parallel, my power number is going to be bigger than 12?
Right. Or yes. And I think that absolutely is a shortcut to this. Knowing that the more resistors you have in parallel, it actually increases the current when you put things in parallel. That's why if you have like too many things on inside your house, the total current goes up through the circuit and it can overwhelm your circuit breaker and it flips and you're like, I shouldn't have turned on the blender and the TV all at the same
Stupid
time.
hairdryer.
Yeah, exactly.
Okay, so potential shortcut there. Obviously, you still got to pay attention. The answer choices here made it a little bit easier because they were so different. But if one was 36 watts and one was 48 watts, then you have to be a little bit careful to go, oh, I have to do the math now.
Right. I really like that you're kind of like thinking about like, how can I answer these questions shorter? That's absolutely something that students should be doing anytime they're reviewing any test. Even if they got the question correct and you're reviewing, if it took you 3 minutes to figure that out, you need to look at this and be like, was there a faster way to solve this? Could I have somehow figured my way to the right answer? I can't tell you how many students are going to like immediately start to sit down and go through the math when sometimes only one answer choice is possible.
Yeah.
And you can just pick the right answer and move on pretty quickly.